Hey everyone! Alright, so today we are learning about finding probabilities and odds. We have a couple of definitions that we need to know. The first definition is outcome, and an outcome is the possible results of an experiment. So, all the possibilities. For example, if you rolled a number cube, what are your possibilities? Well, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So, they're all outcomes of rolling a number cube. An event, the next term, is an outcome or a collection of outcomes. So an example of that is like what's the probability of rolling an odd number? So that's like your event is whatever you're looking for. It could also be like just one outcome, like what's the probability of rolling a 3? That's why it's one outcome or collection of outcomes. Sample space is the set of all outcomes, and that's where our example here is coming from. So once you get these down, then let's look at this example. You flip a coin and roll a number cube. So you're doing both flipping a coin and rolling a number cube. How many possible outcomes are there in the sample space? List the possible outcomes. So we're telling you, we're using a lot of vocabulary in this already. So let's think of our coin flips. We either are going to flip heads or tails. Those are our options for coin flip. Now, if I roll heads, if I flip heads, then I need to roll my number cube. Well, I'm either going to get a 1, a 2, a 3, a 4, or a 5, or a 6. If I roll tails, and then I roll a number cube, what am I going to get? Either a 1, a 2, a 3, a 4, or 5, or 6. So those are my number cube rolls in blue and my coin flips in black. So I used this tree diagram. I made this tree diagram to make sense of my possible outcomes. So this helped me organize. So I know if I get a heads 1, that is a possible outcome. So I can count heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. That's 6 possible outcomes. And then again, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. That's 6 more. So I have 6 plus 6. That means the sample space has 12 possible outcomes. And then it said to list the possible outcomes. So I needed to list it. I have heads 1. Heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. It said to list them. So if you're whining, tough noogies, you gotta list them. Okay, so we're gonna actually continue to look at this, but we're gonna take a break from it momentarily. So hopefully you got all this down. Let me move stuff that's in my way a bit. Okay. I'm going to move this so I can still see it a bit. Or we'll just bring it back into the mix when we need it. And here we go. Turn. Okay, so sorry, I'm trying to make it so that you don't see all the stuff in my house. Okay, so theoretical probability. That's kind of hard to see. There we go. Theoretical probability is all outcomes are equally likely. So P of A, the way that's the probability of event A. So the probability of A is the number of favorable outcomes over the total number of outcomes. This is not new to you. I'm sure you know this already. So if you're rolling a number cube and I said what's probability of rolling a 3, well, how many 3s are there? There's 1 3 out of how many total? There's 6 numbers. So it's 1 6. The probability of rolling a 3 is 1 out of 6 because it says here the number of favorable outcomes over the total. Okay, here's an example. You toss a coin and you roll a number cube. What is the probability that the coin shows heads and the number cube shows a 4? So again, it's the event is both of them, that it's a heads and a 4. We have to think of how the number of favorable outcomes over the total outcomes. Well, we just did that over here, right? So let's look. I have 12 possibilities when I flip a coin and roll a number cube. So I got to find which one is heads and 4. Heads Okay, so I have all these 6 choices, and then rolling a 4 and a heads, that's this choice here. So there's one, of course you missed that, there's one possible outcome out of, what's my total number of outcomes? 12. So for this example, you toss a coin, roll a number cube. What's the probability that the coin shows heads and the number cube shows 4? Well, there's one outcome where it's heads and a 4, and total outcomes is 12. So this is really important to understand our sample space first, and then figure out what's our favorable outcome. So 1 out of 12 is the probability of doing that. Pretty cool. All right, next thing we're talking about is experimental probability. Now I can kind of get this out of the way. We don't need this anymore. Back to here. That's closer. Cool. So experimental probability. It's based on trials of an experiment. Each trial in which a favorable outcome occurs is called a success. So the probability of any event A is the number of successes over the total number of trials. It's not much different with this theoretical probability. This is just in theory, and this is in actual life. Okay, so you spun a spinner 20 times, and please draw this spinner. That's a number 4. So you have this spinner, it's split into 4 equal sections, and this is number 1, 2, 3, 4. You spun this spinner right here 20 times, and it landed on 1, where it's landed right now. It landed there 7 times. Sorry. So the experimental probability is 7 out of 20 for that event, for landing on a 1. Okay? Feel like this is pretty reasonable. Cool. All right, last thing to talk about is odds. So probability and odds. We talked about probability, it's odds time. So odds in favor, it's slightly different than probability. Probability is the number of favorable events over total, not odds. Odds is the number of favorable events over the number of unfavorable events. So in rolling a number cube, and if I said our favorable event was getting a 3, and you rolled it 500 times, and 100 of those times you got a 3, that would mean 100 over, but instead of 500, we're going to think of how many times you didn't get a 3. So that would mean if you got a 3 100 times out of 500, that 400 times you didn't get it. So it would be 100 over 400. So that's the difference here. We'll talk about that in our example. The odds against. It's the same thing but flipped. It's the number of unfavorable events over the number of favorable events. So here's an example. You roll a number cube 30 times. It lands on even numbers, a 2, a 4, or 6, 20 times. Find the probability of landing on an even number. So probability, you got to think of what that was. That was the number of favorable outcomes over total. So what are my favorable outcomes? Well, I want an even number. How many times did I do that? 20 times. And my total? 30 total. So that probability of landing on an even number is 20 out of 30, which we can reduce, and we always will, to 2 over 3. Cool. Let's then move on to B. Find the odds in favor of landing on an even number. Odds in favor, odds, that's that weird one, not at a total. So my favorable is landing on an even number. How many is that? 20. So I have 20 over, and then unfavorable amounts, it's not 30. 30 is my total. 20 are favorable, which means 10 are the ones. That means I landed on 10 odd numbers. If I did 20 even, then it has to be 10 odd. And then you're going to reduce this to 2 over 1. You can also be written out, it's a ratio. So 2 to 1, that's another way to write it. Or 2, which I never use this, by the way. 2, 2, 1, that's totally acceptable too. All right, cool. Next thing, last thing, find the odds against landing on an even number. So against means my unfavorables in the numerator. So how many did I get not even number? In other words, odd number. Well, that was 10. And how many favorable, how many even numbers? That's 20. And then 10 out of 20 is 1 out of 2. So the odds against landing on an even number is 1 out of 2. Another ratio. Super. This is fun. Cool.